Okay, I hope everyone can see my screen. Okay, so welcome everyone to webinar number 10. So we see a lot of familiar faces, and it's great to have you here with us throughout this new experience of a webinar and remote contact. So now we have reached an important topic, which is the smart simulators. So I will introduce the Open Lab, which is the lab that this simulator is based on. And the idea is to give an overview of the solution so that we can introduce the software. So let's get started with a brief introduction of electrical machines. I mean, De Lorenzo has always been a brand known by its electrical machines portfolio. I mean, the yellow machines of De Lorenzo can be found in a lot of universities around the world. And sometimes when we go to a lab, we see some electric machines lab that has been installed like 20 years ago and still working. With this great heritage that we have with electrical machines, we are always still innovating and taking out new products to the market. So in the previous webinars, I mean, we talked about all the electrical machines portfolio. We covered already the bench for to study electrical machines. So the Mac or the Mac TT, the EM test, which is the one that is automated and has the software and the prime mover to study the machine in 4 quadrants. We also have the PLC Mac, CCA for machine automation, CCC for the control, and to study the fundamentals of electric machines, we have our tried and true solution, which is the Open Lab. We have talked about several configurations of Open Lab. The latest one we have launched is the Open Lab semi-automatic, but we also have the automatic or the more traditional, the manual one that has been around for quite a long time. So the idea is to divide the studies of machines between the study of the electric machine itself that is then needed to first to know the machine and then to apply it to a field. So the Open Lab is dedicated to learning about the machine fundamentals, so how to convert energy from electrical to mechanical, mechanical to electrical. So let's talk a little bit more about the Open Lab semi-automatic configuration, which is the latest one that we added to the Open Lab family. So as an introduction, so this is a trainer that was developed to actually as a hands-on platform to study the fundamentals of electric machines. So at the heart of the lab, we have a dissectable set of machines. So we have separated the rotors and the stators in order to see almost inside the machine how the machine is built, to be able to build different types of machines before studying them. So all the system is powered in low voltage, so it creates a safe environment for the students to do a hands-on training on electric machines. So the topics covered is very, very vast. So we start from the principles of electromagnetism and electricity, and then we start studying different types of configurations of machines. So we can study DC motors, DC generators in different configurations. So separate excitation, Schumann series, compound, induction motors with different types of stators, so of rotors, so slip ring, 3-phase, squirrel cage, or single-phase motors as well. With direct connection for dual speed motors and synchronous motors. So actually it's almost more than a collection of more than 40 experiments that cover the most important areas of electric machines. So we have discussed about the core or the heart of the lab, which is the dissectable machines. And then around this lab, we have all the accessories needed to study the machine while it's running and puts the machine in different working conditions so that we can trace the important curves to characterize the machine. So we have the electrical measurement module, we have the mechanical power, so we can measure torque and speed. We have the power supply, the loads. So all these accessories are actually needed to put the machine into some working condition and to measure what's happening with the machine. With the addition of the Modbus RTU communication on board these acquisition modules, we're able to actually connect data acquisition software to acquire all data directly on the software. So this way, the student can put the machine in a specific condition and then trace one point of the curve at the time. So this gives a very flexible tool to study all types of machines. And of course, the Open Lab comes with a very detailed user guide that is starting from the theoretical fundamentals, electric wirings, cablings, and the tables that the student needs to compile and in order to study the machine itself, to characterize the machine. So this is, I mean, how it works in a lab environment. So when you go into a lab and you have the hardware, you take your wires, you follow the manual, and you cable your exercise. Then you measure with an actual tester, you see the results, you trace your curves, and then maybe there is another student coming in and doing the same operation. So now the next step for the Open Lab family is becoming digital. So our popular Open Lab trainer actually goes into a smart simulator version, which is a fully digital version of the 45 experiments in our Open Lab system. And this is a great tool for remote learning and to have different students working on the lab. So actually, now I'll introduce Dennis that you already know, but he will talk more about the solution, and he will do a quick demo also on the Open Lab Smart Simulator. So as for previous webinars, you can always send us questions through the chat. We'll come through the questions at the end of the presentation, but please, as soon as a question comes up to mind, you can always write it down on the chat, and we'll cover that at the end of the session. So now I give the floor to Dennis.
Thank you, Mark.
Thank you.
I'll share my screen with you guys now. Okay. Can you see the PowerPoint presentation? Okay, so Mark has just showed you the Open Lab and discussed a little bit how it can be used to teach electric machines. I wish I had that when I was a student, because it would have saved me a lot of time in my professional life. But anyway, it's always time to learn. So the Smart Sim, the Open Lab Smart Sim, is an answer to an important question that we have been answering in the past few months. How can we keep education up and running, and especially how can we provide practices to engineering students and technical course students? Because engineers and technicians, they need to know a lot of things, but besides knowing things, they need to be able to do things. So the answer, the Lorenzo's answer to that, is a new line of products which include the Smart Sims, and the first Smart Sim in the family is the Open Lab Smart Sim. So it's got a workbench a simulation environment, which is very close to the real Open Lab with the stators and rotors and every component. And it's got also the measurement and power modules. But beside the simulation interface, it's got also the topics that must be studied. So the student may access one topic, and by accessing the topic, the student finds the contents that he or she needs to study and needs to learn to perform the experiments, and by practice learn how the electric machine works and how different configurations of electric machines bring different results in performance, in efficiency, in power, and many other aspects. So by accessing the experiment, the student receives a quick introduction. He understands what is it for. He learns that he's going to go through it in 3 steps, which are assembly, wiring, and measurements. And then he can click the Start Assembly button. So the student will be instructed with how he should assemble the machine. And when finishes assembling it, he may click the Delivery button. When the student does that, the software itself verifies if what the student did is correct. If something of the list, if he missed like the brake here, there would be a white line saying this is missing. If the student got the AC stator here, there would be a red line here saying there is something here that shouldn't be here. So just after completing the assembly correctly, the student is allowed to go to the wiring step. And in the wiring step, he's got all the instructions to work on the wiring. And when the student clicks the Delivery button, then again, the software verifies if the wiring is all correct. So here we have some things missing in white, and we're going to fill the missing ones by connecting them, and they disappear from the list. Another one, and then, okay, it's all connected. So when everything is connected correctly, then the student is allowed to go to the last step, which is to run the measurements in the software. And in that phase, the student may interact with it, turning on or off the power, like we're doing now in this video. Or what is this about? It's a motor brake system. This brake, electromechanical brake, works as a load to this motor. So by varying the power we provide to him, the voltage actually, then we vary the load that is submitted to the motor. And of course, it's going to provide a change on the torque. So we can see here that when we change the voltage here, then the torque changes as well. Okay, so what did we see up to now? The Open Lab Smart Sim is a simulator, like many others that you can know, but it's very different from any product that you know in many aspects. Some of them are what the student has in the lab is the real equipment, is exactly what he would see if he had the real equipment. It's not schematics, for example. There are several electric simulators that you can perform interesting simulators, but using schematics. Here, the student does not see schematics. He sees and interacts with equipment. It just happens that they are virtualized. So the environment is very realistic. And besides that, it's not a simple simulator, it's a smart simulator. So that means the simulator, besides the simulation environment that by itself is very good, it's got also the topics that the student needs to study, the contents, experiments, instructions, and validations. So the learning process is embedded here. It also has a feature so the professor can follow the student's progress. So everything the student is recorded, so the professor may know in which task the student is, and it's got the help in the instructions module. So why is all that so important? Why are we talking about this? Lately, you probably heard the word synchronous and asynchronous several times. And why is that so? Because on remote learning, we have these two moments. The synchronous moment is when the professor and the students are together at the same time, interacting like we are doing right now. And the asynchronous moments are when the student is working without the professor on his own time. So it means Saturday, midnight, for example, Sunday or afternoon, doesn't matter, the time the student has. So this solution helps, it can be used on synchronous moments, but it's very, very interesting for asynchronous activities, because the student just needs to open it and follow the flow. And the professor may know what the students are doing, where they are having trouble, and so on from anywhere, because the software validates what the students do. That means when the student finishes the assembly and validates, the platform is verifying and assuring that the student did that step. When the student finishes the measurement, the platform validates that the student made the measurements and did them correctly. So the professor may follow students' progress. Without these features, the professor would need the student to send a video, a presentation, something that would take a lot of time from the student, that would take a lot of time from the professor, and it wouldn't be that practical. Okay, so in the software, the student logs in, chooses a topic, works on the experiments, and the experiments are divided on assembly, electrical wiring, and the experiment itself, the measurements. So this is the structure of the module in the Smart Sim. Let's get the inductor motor topic. So it's got 4 experiments. In the experiment, the student needs to assemble and validate. Then he can connect cables and validate. Then make the measurements and validate. Just after that, the student is allowed to go to the next one, and the next one, and then go to the next talk. Sorry. So that means that the professor may know exactly where the student is, because the platform makes a register of it. The professor may understand, for example, that most students are taking too much time on the direct current motor topic. And perhaps it's because the professor needs to provide an extra material or something. So the professor has a very good view and understanding on how the process is going on. And the OpenLab Smart Sim brings all the 45 experiments that are available in the real equipment. So this is the process. Student receives the instructions, works on it. If it's okay, goes to the next experiment. If it's not okay, gets feedback. The professor may follow the student's progress, and he may also access a report with all the tasks, all the experiments that the students delivered with date and time. Okay, access methods. What is this about? We have thought about the many possibilities in different institutions, in different parts of the world. So in places where the internet connection is not good, or where there is no internet connection, we can provide licenses through USB dongles, and the institution may use them in the lab computers or distribute with the students. The good part is it doesn't depend on the internet. Bad part, if you lose the dongle, you need to order a new one. Internet authentication. If you have internet connection, it doesn't need to be a good connection. then the student may log in with email and password from anywhere. That means the student can start studying in the school lab and continue on the bus and finish when he or she gets home. The point is, it depends on the internet. And if the institution, if there is internet in the surroundings of the institution, but it's not always available, then the institution may decide to have a local server on the intranet, on the network. So we, in practical terms, we provide a PC to the institution with a server software on it, and the students can log into the application while they are in the institution. The problem on it is it doesn't work out of the school. So the good thing is we can offer institutions with a combination of these three models here, these three methods. Okay, I'm not going to take longer in the PowerPoint. Let's get to the real thing. So I left it working so that we can start by showing it functioning. So you can see here the brake, the torque sensor, the speed sensor, rotors, stator, connections. Here we have the instruments. So watt meter, ampere meter, voltmeter. Maybe you have noticed that we have split the De Lorenzo's instruments in several different ones, so we make it more flexible. Okay, I'm going to do the experiment. What is this experiment about? It's about changing the load at the motor and by different torque measures, take the measure of power, current, and voltage, and make some calculation and study the motor behavior. So the student works this way, changes the voltage supplied to the brake and observes the torque. When the torque reaches a certain value, then the student makes notes of the measurements of the instruments and goes to the next point. All of this is detailed here on the measurement instructions. And the delivery of this task is by filling this table here. I'm going to close the application and do it step by step with you. Let's get the, okay, it's here. All right, so just logged in. Okay, so here we have the environment. As we pass the mouse on the components, we can see the names of it. It helps a lot, especially when we are far from the components, from the equipment. So at any time we can start assembling, but let's go to the instructions. Here we have the topics. Let's go to induction motors. And then we have the theoretical material. If we choose experiment 1, then we have a quick presentation about the experiment. Let's start assembling. Here are the instructions about the assembly. And if I try to deliver the assembly, if I try to deliver the assembly, then the software is going to verify that only these two components were placed correctly and everything else is missing. Sorry, it was my kid here. Things off the homework. So what I'm going to do is I'm going to follow the instructions and place all the components on the correct places. So support of the brake, the rotor, then coupling, then we need the modules, so speed meter, then one phase power supply, Then we get the watt meter, then the other watt meter, voltmeter, torque meter, ampere meter, and the speed meter is not here. This is the best organization. Okay, so we have everything assembled. Now, if I try to deliver it, then, the sensor is missing. Okay, now we can deliver that. Everything is all right. When I close here, we're going to be sent straight to the wiring. We have the schematics and the details that will help us to go through this step. So let's make the connections. And this guy with this guy. And now we're going to connect the brake and the speed meter and the torque meter. So I'm going to close this because it's very easy. We just need to provide power supply to the brake. Then this is the speed meter. So let's connect it to the speed meter. After that, we have the torque meter. Let's connect that. Okay. And then we come to the power measurements. So let's get back again to the instructions. Here we go. Okay, so I need to connect this guy with this one here, and this with this, then this with this, then connect V1 with phase 3. Now we need to get phase 2, connect with the wattmeter 2, then here, then phase 2. Okay, let me make my life easier by changing the position. Phase 2 with the voltmeter and the ampere meter, and then we get the wattmeter with the ampere meter, then the ampere meter with W1. I think there is something missing here. We need to get this white line, these white connections here are missing. So I'm going to do it right now. Here, U and U, and then that must be connected to phase 3. Okay, I believe I did everything correct. So I'm going to make a mistake just to make sure that you see the validation not validating. I'm going to short circuit this power supply. Very bad thing to do, right? Okay, deliver wiring. Everything correct, but there is a feedback here that said, oops, something is wrong. And what's wrong? I connected the positive and negative poles of the power supply. I'm going to take it out, and by mistake, by accident, I'm going to take this connection out too. And when I try to validate that, then I received another oops, that there must be something to be fixed, and the positive pole of the electric brake must be connected to the positive pole of the power source. I connected it now. And now finally, when I deliver, everything is okay. And when I finish it, then I go straight to the measurement step. And in the measurement step, I'm guided on setting things up, starting the motor and working on the measurements. What do I need to do? What it says here is that I need to, as I said, adjust the voltage supplied to the brake, observing the torque. And for different torque values, I need to make notes of the measurements in instruments and make some calculations about efficiency and other ones. So let's do that. I need to get the power supply, put in DC mode, turn it on. So if I do something here, nothing happens, of course, because the motor is off. I'm going to turn it on. Now it's working. And now I can adjust. If I adjust here the voltage on the brake, then I can see the torque value here. And what is here in the instruction is different values for torque that the student needs to bring here. So he can, by getting those values, he may make notes of the other values and study the performance in other aspects of this electric machine. So this is what we have in the Open Lab. This is what it is about. These several possibilities that it brings provide the possibility to study DC and AC motors in many aspects. So it's a very, well, we like this tool a lot. So guys, this is what we have for now. And as usual, we are available for answering any questions that you may have. Let me see if we have something on the chat. Nothing yet. Well, I have some questions that are normally brought. I'm going to bring it to the screen again while you perhaps think about something that you want to question. So let me get to the PowerPoint. It's going to work if there is a USB dongle connected to the software, to the PC, or if the student has internet or connection to a server to authenticate. How many students can use the software? The number of accesses that the school buys. So it means the number of dongles or the number of access to the server. Is it necessary to have internet all the time or just to log in? Of course, to log in is mandatory, but the application from time to time tries to talk to our server, sends a message and waits for a feedback. So it is necessary to have connection all the time, but it's no problem if the connection falls sometimes. So if the student has a very unstable internet connection, when the application tries to reach the server and can't, then the application is going to try again and try again. And just if it stays like for 1 hour without any connection, then the application is going to stop working. If it's working on internet authentication. If it's working with a USB dongle, of course, it doesn't depend on the internet. And so the next question, which is about the quality of the internet, the answer is you don't need good internet connection and you don't need a big data package, because the data exchanged is just few data, and it's from time to time. So it's not much data, and it doesn't require high speed or high quality of the internet. So Mark, it's your show time, or Rolandinho. Oh, we have a question here. Is it possible to select the colors of the LEDs? The colors of the LEDs. The LEDs or the cables?
Yeah, the leads. So the cables.
The cables. Yes, it is going to be possible in the full version. In the demo version, it's not going to be available. But in the full version, yes, the user will be able to choose the colors of the cables. The last permanent. I think there is one question here about the licenses, and I believe we have the two options: permanent licenses or temporary licenses. So in case of internet authentication, the customer receives just password. Yes, username, actually email. The user needs to have a valid email account, and he's going to receive a password to log in. Exactly. The technical characteristics of the machines in the simulator are similar or equal to, yes. When we built the simulator, we built it using electric simulation technology, and we took care of making the results, the outputs, very alike with the real one. In some points, it can be not equal, but it's going to make sense. So it's going to behave like a 300 watts motor. So it's going to behave very close to the real one. Carlos. The other question that always comes up is, when is the demo going to be available? And the answer is, it's going to be available in a few days. Giovanni is taking care of it. How is the student communicating his progress to the teacher? In the case of using dongle for homework on the internet, is the monitoring by the teacher automatic in the case of, okay. When the student, the answer here refers to the conditions of the student. Let's pretend the student doesn't have internet at all at home. So the only way for the student to, let's say, upload his progress to the professor would be bringing a file on a pen drive and getting to school and plugging it. So the student will have a dongle and a pen drive and the dongle home, right? So after doing the exercises, a student would need to have a pen drive to save his progress, then go to school, plug the dongle and the pen drive, and then upload his progress to our server. This would be the only way that a student without internet at all at home to do this. If the student has internet at home and yet needs the dongle because the internet stays for long times offline, for example, then we will probably have a feature that when there is internet connection, the information is uploaded. But by now, what you will receive and what is going to be available in the first version is that if it's dongle, it's offline. If it has internet connection, then it's going to be synchronized with the server. Anyone? If a school provides virtual PCs to students or remote PC access for students, can the software be installed on the virtual PC so the student access it remotely? If, Roberto, if that happens, that means the student has a very good internet connection, actually. So he'll be able to access a virtual PC remotely. Thank you, Youssef. So if we, it can be done this way, but the virtual PC and the host PC, where the virtual PC is hosted, needs to have power and rate requirements to run the Open Lab properly, because it's a 3D simulation software, like a game. So my point here is, if the student has good internet connection, we can provide the access through internet authentication, and the student can install the application on his own PC directly instead of accessing a remote PC. By your question and without knowing further details, I can't think about why to have a solution like that. It would cost more to the school, I believe. Does it work under Moodle platform? No. It's a separate software. To work on the Moodle platform, we would need to build it on a SCORM standard, and it's not built that way. Things that run into Moodle platform are kind of limited, so we decided not to go that way, so we would have a better product. What is on our backlog to discuss later and to new versions is an integration to Moodle, so that the student could do the exercises on the smart sim, and the smart sim notifies the Moodle about them. But it's not going to be available in this version, and it's just one point that is being evaluated. How many e-learning products do you, I think it's do you have so far? Yeah, do you have so far? We have the DL VFA 4.0, which is for industrial automation. We now have the Open Lab, and we're going to have the virtual process control in a month. So the answer is 3. But I've got to say that we have a list of requirements from different customers in different countries in the world. So the family of e-learning product tends to grow very, very fast. Does the software require higher qualification PC? What I can tell you is I'm a professor, like some of you guys may be, and I've been using these solutions on a classroom, especially VFA 4.0. And I have students who have i3 PCs with like 2 gigabytes of memory, and it works. Of course, the performance, it depends on the processor of the PC, it depends on the memory, but it depends a lot on what the student has installed on the PC. So there are students that have PCs that meets the minimum requirements that we recommend, which is a i5 with 4 gigabytes, but sometimes the student has installed so many things that consume memory and processor that it doesn't work as well as an i3 with 2 gigabytes of RAM memory. So I think an i3 with 2 gigabytes is no big deal. What happens with students who have computers that are old and with low performance is normally they format the PC or uninstall some things so the PC gets a breathe and works well. Can I integrate an experience on the Moodle platform? Carlos, I think we need to discuss that in more details so that we can understand what is the situation and what we can do. So the technical answer is we can make the product, the smart sim, talk to the Moodle platform to receive like the experiment the student should do and send back the experiments that the student did. But to be clear, it's not available on this version, and we have that on our roadmap. So the best thing to do is we talk in details about this. If you have a specific customer, we should have a look at the specific situation to give you the best answer and way solution. And Hamada is asking, the student tracking dashboard is within the platform. Yes, the software itself has a interface that the professor may click on that and choose a student and see the progress of the student locally. So if, let's pretend the student, the school buys licenses for a lab, for presential learning. So that means the professor may go on a specific PC and click on the button and see the progress of the students on that PC. So the progress is going to be stored on a file on that PC. It's not going to, the student needs to work always on the same PC, if it's this way. If it's on internet authentication, then it will probably be like DLVFA 4.0, that it's accessed through a dashboard portal. Everyone was quiet at the beginning, but in the end, very interesting questions came up. Anyone else? Mark, I think it's with you again. Or Rolandinho.
Yes, for me, I don't have any specific question. I think apart from the fact of maybe needing another session or making another time to go through this video, because for sure this is going to be one of the no, not it's going to be, it actually is another great addition to the line that we have. As Mark was explaining before, you know, the electric motors, electric machines are have defined the Lorenzo and have made the Lorenzo success. And now also this is a sign of us adapting to the changes in technologies, introducing also the different e-learning platforms. And as we did mention also in the previous webinar we had with Dennis, you know, this is the perfect time to actually start promoting these. And for sure, we will start to see, and you yourselves, you will start to see a great need for these different e-platforms, e-learning platforms. So from myself, I don't have any other comments. Once more, we thank you all for having made the time to participate. And do continue to feel free to actually encourage some of your colleagues and collaborators to also come and participate in the different webinars that we have. As we've been doing, we have webinars every week. On occasions, we might maybe have a gap of 1 week. But the idea is to continue to be consistent, and feel free also if you have specific line of products or our laboratories that you would like us to go through, either to go through again or to start talking about it. Do prompt us also on those, and we will get our teams together to start also working on a webinar. Should you at some point, this is me going off the script as always, but should you at some point feel that you are able to put together some of your colleagues or those who have like specific clients also to bring a group of clients that they would like us to present to, specific equipment, specific labs, be it those we have done before or new ones, do feel free to also let us know, and we can also possibly consider making a tailor-made webinar, and that can be of great support should you need it. So that's for me, and thank you very much, Dennis, for that great insight. Thank you, Mark, as well. And yes, looking forward to see you guys soon. My colleague Margaret will send an email to everyone with a copy of this presentation as a video, and also the different slides that were presented for you to be able to go through them, and feel free to also share them again with your different contacts. And then we'll be in touch with you again in a separate email to inform you about the next webinar and the topic that will be taking place. Thank you. Have a great continued week, and see you next time.
Thank you.
Thank you, everybody.
Bye bye.
Bye bye. Bye bye. Bye bye.
Bye bye.
Bye. Thank you.